Hello everyone, welcome to week 3 of Codivate's introductory Python class. Our focus for today will be lists and tuples. Alright, so why do we use lists? Lists in Python are useful if we have a lot of data we want to store, but we don't want to have a different variable for each piece of data. For example, if we have a list of student names, or a to-do list of some activities or tasks. Now, let's get into the actual syntax of creating a list. So lists have similar assignments to variables. So we have the list name on the left side of the equal sign, similar to how we have the variable name. So just like variable names, we choose the list name. There's no specific type of name that we have to choose. We can call it anything we want that describes the data within it. We need the equal sign to assign the list values. It is our assignment operator that we learned about last class, stays the same. List items in Python are contained by square brackets. So each value inside the list is called an item. So here we have 1, 2, 3, 4, 5 items, and this current item is a Boolean that is false. So you can see that in our list here we have all different data types, and that will still work out in Python. Usually, however, it's more useful if we have the same data type throughout the list. Here you can see, as I mentioned earlier, we have integers, floats, strings, and even Boolean. So each item in the list is separated by a comma. If we want the list to work properly, we need a comma. Now, let's go over one of the easiest things we can do with lists, which is find its length. If we want to know how many items are in the list, we can use the len function like this. We have the word len, we have the word len, and the name of the list inside parentheses. Since there are 5 items in my list, calling the len function on it will give us 5. If we're not sure what we want in the list to start out with, we can create an empty list and then add things later on. And in order to make the empty list, we can do something like this. Just have the 2 square brackets. Alright, let's move on to our next slide. Once we've made our list, we can start using it. If we want to access a specific item in a list, we have to use the index of that item. We can use positive indexing for this. So indexing starts at 0. If we want to access the first item, the index would be 0. And we may be used to counting starting from 1, but computers start counting at 0. So we have index 0 has the value of 1, index 1 has a value of 4, index 2 has a value of 9, and index 3 has a value of 25. So, in order to get a value from a list, what we'd have to use is this syntax. We'd have to use the name of the list, followed by square brackets, and inside the square brackets we put the index. So, based on what we talked about indexing and lists, what do you think this will print? You can pause the video and give it a shot. Alright, I'm assuming you paused the video, and now let's go over the answer. If we were to print this item in the list, it would print 9. As you can see in our table here, we have the index 2, which corresponds to 9. And if you want, you can start counting from the beginning, 0, 1, 2. That matches up with what we got before, 9. We can do many things with this syntax. Besides just printing, we can also assign an item of a list to a variable, or we can change it. So if we wanted to change a value in a list, we would have to use this syntax. We would specify the index with the list name and the square brackets, like so, and then we use the assignment operator to assign the new value. In this case, we are going to the 0th index in the nums list, in assigning that the value of 2. So what's happening here, we go to the 0th index, replace this 1 with a 2. And if we were to print this list, it would print 2, 2, 3. Let's move on to our next topic for the day. Now that we know how to pull one item from a list, let's learn how to take multiple items from a list, or a few items. So this is what we call a slice. If we wanted a slice of the items in the list, we would have to use this syntax. We have the list name, followed by square brackets, and inside those square brackets we have the start and end index separated by a colon. So this will give us a list made from the original list. So the new list that this slice creates will start at start index, but it will end at end index minus 1. Let's take a look at an example so we can understand what this means. So here we have our square list, and we are making a slice from index 1 to index 4. We have to remember, we have to do end index minus 1. So we have to look at everything from 1 to 3. So we know this is 0, this is 1, this is index 2, and this is index 3. So from 0, 1 to 3, because we have to do end index minus 1, we get the values 4, 9, and 25. And that is our output when we run this code segment. Now let's look at list slices without a parameter. If we do not put one of the inputs for start or end index, Python has default values just in case. If there's no start index, the start index defaults to the start of the list, which is 0. And the end index just remains whatever you input. So in our case here, we have 1, 4, 9, 25, and 36. And if we were to use this syntax, we assume that the start index is 0 and the end index is 3. And that would give us this list. Similarly, if we leave the end index blank, it will assume the end of the list. So we'd start at whatever the start index that's inputted is, and end at the end of the list. So here, we start at the 3rd index position, 0, 1, 2, 3, 25, and we take the slice of the rest of the list, which gives us 25 and 36. Now let's get some practice with list slicing. Pause the video, write down what you think each one of these print statements will print, and play the video when you're ready to review. Alright, let's go over the answers. For the first one, since all of the parameters are left blank, the start index is assumed to be the start of the list, and the end index is assumed to be the end of the list. So the entire list is printed out. Obviously, this is not the best way to print the whole list. We could just print Fibonacci and we could get the same result. Alright, let's move on to the next one. So from Fibonacci 2 through 5, let's look at the indices 0, 1, 2. So this is where we start. 3, 4, 5. Remember, we don't include the 5, so we end our slice here. So we slice from here to here. That gives us 1, 2, and 3. And now let's do the last one. We know that our end index is 3. Let's count it out. 0, 1, 2, 3. But we don't include it, so our slice ends here, and we take the first 3 values. 0, 1, 1. Now let's look at some list methods. If we want to manipulate lists, there are a lot of inbuilt ways we can change them. We'll go over all of them today. So the first one is list.append value. And what this method does is that it will add the specified value in parentheses to the end of the list that it's being applied to. And here we put the list name, we do .append, and in parentheses, we put whatever value we want to add to the end of the list. Let's take a look at an example. Here we have the evens list, has 2, 4, 6, and 8. We append to it the value of 10 using this syntax, list name, dot append parenthesis value parenthesis. So what this does is it will add a 10 to the end of the list. And you can confirm that. Once we print the list, you see we get 2, 4, 6, 8, 10. The second list method we will talk about is list.clear. This one's a pretty simple method. You put the name of the list, you do the .clear, you put the parentheses, and our list becomes empty. So if we were to clear the evens list, we would just get an empty list, like this, with the square brackets. Our next method is the list.copy. What this will do is it will return a copy of the list. So for example, if we had evens here, and we wanted another list with the exact same values, we could make another list using the copy method. Evens 2, that's the name of our new list, and to that we assign evens.copy. So I'll copy all the value in evens and give it to evens 2. So when we print evens 2, it will have the same values as evens, since it's just a copy of it. The next method is the count method. If we want to count how many times a certain value appears in a list, we don't have to write a whole complex algorithm. There's an inbuilt method that does this for us, and it's conveniently named the count method. We put the list name, dot, count, and whatever item we're counting. So it will return the number of occurrences. In our example here, in the nums list, we have 1, 2, 2, 3, 3, 3. If you were to print nums.count, and then in parentheses 3, it will count how many times 3 appears in the list. Here we can count 1, 2, 3. So it would print 3. If you were to do nums.count2, then you would get 2. If we were to do 1, it would be 1. If we did a number that wasn't even in the list, it would just be 0. Alright. Our next method is the extend method. And this we would use if we wanted to append the values of a list to the end of another list. So we can't directly use append because this would put the entire list in one position and would create a complex two-dimensional list. We want a simple one that has all the values separated by commas. So here, if we have an evens list and an odds list, and we do evens.extend odds, this will add everything from odds to the end of evens. If we were to print evens, you can see we get 2, 4, 6, 8, 1, 3, 5, 7, which makes sense. We have 2, 4, 6, 8 for evens, and it's being extended by 1, 3, 5, 7, which is odds. Our next method is the index method. So this will give us the index of the first occurrence of an item in the list. It won't give us the index of all the items, but only the first occurrence. In our example here, we know that odds has 1, 3, 5, and 7, and the index where 5 is 2. And that lines up with what we learned, 0, 1, 2. Let's look at a few more methods. If you want to insert an item into a list, we can use the conveniently named insert method. So this one takes two parameters that are separated by commas. The first parameter it takes is an index. The second parameter it takes is the item you're inserting it. So what this will do is it will insert this item that you input at the index that you input. So in our case, we have a list called evens, has 2, 6, and 8, and we're inserting at the one index position the value 4. So 0, 1. So over here at this position, we're inserting 4. And if we were to print that list, you could see we get 2, 4, 6, 8. Our next method is the pop method. So what this method will do is it will remove whatever item is at the index we input inside the list. Let's take a look. We have a nums list that has 5, 6, 7, and 8. We do nums.pop, and inside that we put the index 2. So we can count 0, 1, 2. It should remove the 7. If we were to print nums after doing this, you can see it no longer has the 7. An interesting thing about the pop method is that if we assign it to a variable it will take whatever value it popped out and give it to that variable. So here, since we're popping the 7 out, it would give x a value of 7. We can confirm that by printing it out. But we don't necessarily have to assign it to something. We could just pop it out if we want to, and it will still work. Our next methods are remove and reverse. If you want to remove an item from a list, instead of specifying the index, we want to give them the actual value, you would use the remove method. In this example, we remove 8 from nums, so nums will no longer have the first occurrence of 8 in it. So if, as you can see, we have our nums, 5, 6, 7, 8, nums.remove the 8. Now we print nums. It no longer has the 8. So remove uses the value, and pop uses the index. Another method is the list.reverse method. As you can guess, it reverses the list. Here we have nums initially 5, 6, 7, 8. We apply the reverse method. Once again, takes no parameters, but you still need the parentheses. If we were to print that, you can see it's in reverse order, 8, 7, 6, 5. Okay, we are approaching the end of our methods. The next method is the sort method. So what this will do is it will sort a list in increasing numeric order if it's a bunch of numbers, or in alphabetical orders if it's a lot of strings. Here we have numbers, and if we were to do nums.sort, it would rearrange this list so that it is in sorted order, from least to greatest. You can see we have all these values, and now they're in the order, increasing order, 1, 1, 2, 3, 4, 7, 7. So on the flip side, if we wanted to reverse or flips or sort something in backwards order, instead of using two methods, list.sort and list.reverse, we could do it all in one method. And the way to do this is to use the reverse equals true parameter. We would just write reverse equals true inside the nums.sort parentheses, and it would understand, okay, so we want it to be reversed. We don't need to put reverse equals false for the regular one because it just assumes that's the default. Okay, so if you were to try this with the same nums list, and if you were to print that new list after it's been sorted reverse, it would print 7, 7, 4, 3, 2, 1, 1. Let's take a look at our last list method. This is one more way to sort lists, and we would use this if we don't want to change the list itself, but we just want a sorted copy of it. We can use, in order to do this, we would use the sorted method. That is what it's called. If we call sorted on a certain list, our output would be the list in an increasing order or in alphabetical order. Here we're printing the sorted method called on a list, and you can see it rearranges the values in increasing order. But we have to remember there's a key difference between the sorted method and the list.sort method that we just looked at. Sorted will give us a new list, but list.sort will change the list it's applied to. Let's take a look at some common list errors to avoid so we don't make mistakes like these in the future. So if you want to access an index and that index happens to be out of the bounds of the list, we get an index error that tells us that our list index is out of range. Another common error is adding the incorrect number of inputs into a method. An input is also known as an argument in Python. An argument is basically anything we put in the parentheses that helps Python understand what we're doing with the method. List.clear doesn't take any parameters or arguments. It just clears the list. It doesn't need any information. So it's confused when we give it a 3. That's why we get this type error. Clear takes no argument, and we gave it 1. And another method that could potentially face an error is the sort method. And this would happen if we have both strings and integers inside a list, and we try to sort it. Since we don't know what comes first, do strings go first or do numbers go first? can't sort it because it can't compare strings and integers. Like usually for sorting, we're making sure every value is less than the next value. How would I know if a number is less than a string? It doesn't make sense, so Python completely avoids doing that, and it would just give us a type error. Let's do a practice problem with lists. You can pause the video, try to go through this, and then you can play it once you've got an answer. Alright, let's go through this problem line by line. In the first line, we create a list called myList and we assign it some values. In the second line, x is being assigned the length of the list. Let's count that. 1, 2, 3, 4, 5. So we have 5 items in the list, so x is getting the value of 5. Now what we're doing is we're removing from the list 5. We know x is 5 from our previous line. So we're removing this 5. It won't remove an index, it will remove an actual item. So we're getting rid of this 5. So now our myList only has 1, 2.0, high, and false. Next line. Y is being assigned the length of the list. Remember, we got rid of this 5, so we only have 4 values remaining. So y would get the value of 4. Our second one doesn't have anything to do with lists. It's just a simple division operator. Y is being assigned its previous value divided by 2. So its previous value that we just got here is 4. 4 divided by 2, we have to remember it's a float, is 2.0. We can confirm if we print y, we get 2.0. Now let's move on to our next topic for the day, tuples. Tuples are similar to Python in the sense that we can store multiple values in them. They also have some similar methods we can use with them like len, count, and index. Even accessing using square brackets remains the same. Indexing and slicing syntax is also the same. So these are some of the similarities we have with lists, but there are also a few key differences. Tuples use parentheses instead of square brackets, and tuples are immutable. Immutable means that it cannot be changed after it is created. You cannot use indexing to change an item in a tuple. So here is an example of a tuple. Tup is being assigned apple, comma, red. Here. So we are creating a tuple named tup that has 2 strings, first name and last name. And now what we're trying to do here is using indexing like we did with list to change a value in the tuple. But we know tuples are immutable, we can't change them. So this will cause an error. And we get a type error. Tuple object does not support item assignment. What we're doing here is assignment. It's remember, equal sign is the assignment operator. So if we do want to change a tuple, there are some ways to get around it. Or if we want to change a list so that it cannot change, we could also do that. And this is through casting. We looked at typecasting last time with strings, ints, and floats. Now let's look at doing that with tuples and lists. If we have a list of letters here, A, B, and C, what we could do is cast this list as a tuple. So now we have a tuple of letters, tup letters, because we use tuple and then in parentheses the list name. If we were to print this, you can see that now we would have the parentheses instead of the square brackets, which would indicate that it is indeed a tuple. We can go back to having a list by casting the tuple to a list. And if we were to print that list, you can see we're back to a list because we have the square brackets. These are the exercises for the week. You can pause the video, try to work them all out, and once you're ready to review them, you can play the video. Alright, I'm assuming you had a go at it, and we will go through the exercises now. For the first exercise, this is one of the approaches. We would create an empty list that has a value of fruits, and we append to it the orange using our list indexing. We append to it the apple 0, 1, 2, 3 is at the third position. And we do the same thing for banana. So now we have orange, apple, and banana. So now what we want to do is sort them in reversed order. And we can also do a similar thing with nums. We could add to nums a substring or sub list of the original list using slicing. We can append to that another item 0, 1, 2, 3, 4. We would append the 5 and we would sort that. That would print our list to get them like this. So there's some things that you want to make sure you notice here is that we are sorting fruit in the reverse order because orange, banana, apple are in reverse alphabetical order. And we are sorting nums in the regular order because 1, 3, and 5 are increasing order. And that is how the desired output is. There are some ways that this solution is not the most efficient, and that's because we could have just appended everything we wanted in the correct order. But this solution uses a lot of the approaches and a lot of the methods that we discussed today, which is why it's the example solution. So our solution for exercise 2, which was to remove an item from a tuple. So there's two main approaches. One that involves slicing. So we would make a tuple and assign to that tuple a slice of the first two items and a slice of the last item. And we would not include English because that's the one we want to remove. And if we print that, you can confirm it has the desired output. Another way to do this is to use what we did with typecasting and lists. We would have to make a separate list for the langs that is just the list version of this. We would use our casting as a list. We would pop out English using the pop method and the specified index. We could also use a remove method here and write English. So once we're done with that, once we've worked with it as a list and removed it, we can cast it back to a tuple and assign it to the original lang top. If we were to print this, we would confirm that we get the same thing. All right, here's our last exercise for the day. It's solution. When we add two lists together using the plus sign, all of the second list items are added to the first list. So when we test using this example, A, B, C, X, Y, Z, we add list A and list B, we get A, B, C, X, Y, Z. So this is similar to the extend method because we're kind of combining two lists into one. So that wraps it up for our presentation for this week. If you have any questions, you can reach out on the Discord, and see you next week for week 4.